Hiyo, welcome back everyone. My name is Adil Al-Romeshi. Today I will be teaching you another Calculus 2 concept. This one is a special one. It's going to be about area bounded by the curves. Now, you might be thinking, right? How do you make the relationship between the curves purely based on the area? Well, you have the integral. You're going to use the integral, right? In this case, the definite integral, f of x minus g of x dx. Now for that, we got example 1. Find the area bounded between y equals x cubed and y equals 2. In this case, you have y equals 2 and y equals x cubed. And for this here, right? For this here, I always like, even though it's not volume and you don't have to determine, obviously the inner radius, outer radiuses, because there aren't any radiuses in there, I still like to use that notion to justify which one is the f of x, which one is g of x. And I think it's quite clear that you also do that to prevent any sort of negative area. You can also use that logic where when if you, let's say, use x cubed as f of x and y equals 2 as g of x, right? You are most likely going to have negative area, sorry. So moving on, we're trying to find the shaded area bounded between these two curves, right? First thing you need is the intersection points. The intersection points are very crucial because you're not always going to be dealing with one area, but sometimes you have to cut areas in half, and that can be a bit tricky. So I will be definitely showing you guys more examples of situations where you have to find multiple areas depending on certain cuttings and all that good stuff. So the intersection point, the way you find it, you put those two curves together. You get x cubed equals to 2, and obviously you cube root both sides. X is cube root of 2. Now the intersection points are the points where those two curves share the same x values, right? And what you have here is, now I have this equation, the integral x between 0 and cube root 2, right? See here, the, interval notation. 2 minus x cubed, remember it was f of x minus g of x, right? dx. Now, the way you do this, if you need a reminder or a refresher in your mind, is you put cube root 3, right? But before you do anything, you have to obviously find the antiderivatives of these. This is very straightforward, right? When it's addition, subtraction, you can just go ahead and find the antiderivatives of each term. So 2, it will be 2x. And for x cubed, right, since it is x, x of n, the antiderivative of x to the power of n is x to the power of n plus 1 over, well, n to the power of n plus 1, and then multiplied, right? So another term multiplied by it will be 1 over n plus 1. So you get x cubed is 1 over 4 x to the power of 4. So what you end up getting for the area is 1.89. And you just, well, if you think about it, the zeros will cancel, right? The zeros will cancel because it doesn't mean much, doesn't mean anything. And you're just accounting for the cube root 2. Cube root 2 into the 2x term, and then minus 1 over 4 cube root to the power of 4. And that's how you find the area bounded between y equals x cubed and y equals 2. Pretty straightforward. I will be going through more examples very shortly. Probably later on in the day, I will post 1 or 2 more of the area bounded by the curves, and then I will move to volume. So thank you for watching, guys, and if this video reached out to you and you like my content, maybe you want to see other types of content, please let me know down below. And yeah, till next time, take care.